So, our presentation that we start now will be about change tracking. I take a few seconds to introduce the fact that W3C introduced community groups. I think it was already operating last year at the last XMLPrague conference. Seems like a very healthy stuff now that we have 1 year back. And there is many community groups around XML that have started, so if you're interested in joining, you have to look at someone has mentioned at the, Patrick mentions the PPL, printed page layout community group. Now we'll be discussing about change tracking. There is a lot of community group that you can join. You don't need to be a member of W3C to join in case you have any questions. So, it will be presented by our fellow from DeltaXML. They know a bit of their stuff, so it will be about change tracking, and it had been already introduced this morning by George when he talked about this legal document. So,
okay. Thanks very much, Mohammed. I'm Robin LaFontaine, DeltaXML. The purpose of the paper that we've written and this presentation is to report on some work that we've done in change tracking, originally within the OpenDocument format, but as Mohammed has said, more recently moved into the W3C community. So I'll give you a little bit of background about what has happened, and then I'm going to hand over to my colleague Tristan, who will do the much more interesting technical stuff, which I'm sure you will enjoy more. So, just a little bit of background. It started off, as I say, in OpenDocument. We got involved with OpenDocument quite a few years ago when we were asked to write a comparator for OpenDoc for financial regulators with big documents and big tables and things, and they wanted a good comparator. So we got involved with OpenDocument at that stage. But the change tracking within OpenDocument is not very widespread and not very good, has not been implemented particularly well across different applications. And we were asked, in fact, by NLnet to look into that and to suggest a way that it could be improved. So we did that, and we went with that to the OpenDocument community and worked with them on it. In the end, they decided that they wanted, rather than going for a document-centric, an XML-centric approach to change tracking, they wanted to do more of an application-centric approach. But they acknowledged that the work that we'd done was certainly of interest in terms of general XML change tracking. And at the same time, there was interest from other communities, in particular the DITA community, who said, well, we don't have good change tracking within DITA, and we'd like something better. But they saw it not so much as a DITA problem, but as an XML problem. So they were keen to have a solution that they can use, rather than a solution that they'd actually developed for DITA specifically. So with those things happening, and then there were other groups, people who had other schemas in XML, who were also interested in change and change tracking. One of those was StratML, which was looking at project planning and changes to projects and plans, obviously, which is very important, and being able to record and remember those. So in November 2012, just last year, a new community group was set up within W3C with support from Liam Quinn to look specifically at this area. And there are, I think, some 23 participants now. The chair is Mohammed. That's why he was giving you a plug for it just now. And as I say, about 23 participants, of which I think there are 4 or 5 here. If you are a participant, could you put your hand up so we can just see George and Norm and Nigel, Mohammed, 1, 2 others. So quite a few represented here as well. Now, I think the thing about standardizations is that it's really important that there is a will to have a standard. And the next slide I'm going to show you looks at some of the benefits of a change tracking standard. And I think it's terribly important to think about that and to think about whether those things are right. Because unless there is the incentive there and the desire to do it, it simply won't happen. So here are some of the areas that I think are important in terms of benefits of a change tracking standard. So, and it covers both the users and the software developers. So just going through these, the first one is that documents with track changes could be moved from one XML editor to another. At the moment, you can't do that. As you know, there are proprietary ways within each XML editor of doing change tracking. They're actually quite similar, but they're sufficiently different that you can't move a document across. So from a user's point of view, if there was a standard and that was used, then that would enable that to happen. And then moving on to the XML editor applications themselves, their nightmare scenario really is that DITA has one way of doing change tracking, DocBook has another way of doing it, S1000D has another way of doing it, and they've got to implement dozens of different ways of doing change tracking. And that is obviously a complete nightmare as far as they're concerned. So again, they're very keen that there should be only one way of doing it. The third one there, any document type could include change history. Here, if there was a standard way of doing it that applied to any XML, then certainly in theory, any XML that exists there at the moment can fairly easily add change tracking. And that, again, is a huge advantage as far as schema designers are concerned. We can't go into all the detail of that now, but again, a huge potential advantage there. And then, obviously, the last point there, that if there's a standard way of doing it, then it's going to be much easier for software developers to produce good software that will handle change in XML. If they've got to do something different for every different format, again, that's a nightmare scenario, which we don't want. So I think there are many reasons why a change tracking standard would really be useful for most of the XML community. And I think it would make XML that much more useful and usable. So with that introduction, I'll hand over to Tristan to talk more about the technical detail.
Thank you. As Robin says, I'm Tristan Mitchell. I'm also from DeltaXML. And I'd just like to take a look at where we're going from now. I will look at the aims of the approach that we took. Robin's already covered some of that, but I won't labor that too much. And then we'll move on to the technical details of what we've already done. There are obviously some basic constructs you need for representing change, addition and deletion being the simplest forms. We'll take a look at that first, look at how we define those, and then think about some of the problems that are still present if that's all you've got. Then we'll look on to some more constructs that we've done for improving that, and hopefully we'll have some time for a demo at the end and some questions. So our aim has been to talk about change in change transactions. What do I mean by that? A change transaction is a single reversible item that has happened to a document. It's a single edit and save scenario. Those have been defined in a particular namespace. We'll look at some examples of that later on. So all of the elements and attributes that we've added to show the change tracking are all in separate namespaces so they can easily be identified. So the changes are represented in the XML itself in a generic way. Robin already mentioned there's that generic representation that could be used for any XML format at all. It doesn't matter whether it's DocBook, whether it's DITA, whether it's whatever flavor of XML you like. This approach will be useful for it. It's important that all changes can be represented, and that's so that it's possible to revert any change. There's no point in doing change tracking if you can't go backwards through the stack, if you can't reject changes that people have made or have that kind of accept, reject functionality. So that's important. And another thing we've tried to do is define a the formats so that it can be easily converted into processing instructions. If you were in the Oxygen users meetup yesterday, you will have heard or seen Alex showing us the processing instructions that Oxygen uses. George has spoken about it this morning as well. The beauty of using processing instructions is that if your change tracking is represented purely in processing instructions, you can then validate the document against its standard grammar. So DITA with some change, the processing instructions showing change is still a DITA document and can be validated with a normal DITA validator. So let's take a look at the first steps that we've implemented. The simplest change representation, as I've said, is to add and delete elements to your XML. So here's a simple example. As you all know, us Brits love talking about the weather, so all of our examples are going to feature the weather. There are white space insertions to make it look pretty, but yes, I know that perhaps that might change the meaning of the example, but ignore the white space and hope that it looks pretty. So this paragraph has been inserted. The weather in February in Prague is cold. Perhaps they don't agree with that here, but I feel like it's cold. The way that paragraph has been shown to be inserted is with these two attributes in the Delta namespace. We've got an insertion type, which at the moment is insert with content. There are other values for that attribute, which we'll come on to later. And then there's a reference to the change transaction I mentioned earlier. That's an arbitrary identifier, which here is the CT1234. So that's a nice simple way of showing that this paragraph element has been inserted, and the change transaction reference will take you to the place where the author is defined, the time that happened is defined, and any other metadata that you want to associate with the change. And we move on to a deletion. It was raining when I left the UK. That paragraph has been removed. You can see that we've wrapped it in an extra element, the Delta removed content element. That element has got an attribute which again refers to a change transaction with all the metadata associated with who did the change. And the reason we've wrapped the content is because that provides a standard way which is used throughout this change tracking. Any content that is removed is wrapped in one of these removed content elements, and that takes the paragraph out of its original context. It's important to do that so that it's easy when you're looking at a document to see what the final version of the document is. So if we wrap deleted content in this element, then that enables us to ignore it when parsing the document if you wanted to just see the final version. So that's the basics, element addition and deletion. It's possible to use that to track any other kind of change. So it's possible to use those two constructs to track an attribute change. If you've got an element with an attribute that gets added, all you do is remove the element without the attribute and then add the element with the attribute. That's not very good, though. What we want is a finer granularity of the change. If you do it that way, you can't see precisely what the changes were to that element. If there was an attribute change and a text change, you can't see that. So what we want to be able to do is to have that finer granularity. So attribute changes have been defined in their own way. And here's an example of adding, removing, and modifying attributes. You'll see each paragraph has got an attribute change. They are all placed in encoded attributes in this AC namespace, AC standing for attribute change. They've got arbitrary names. It doesn't really matter what the name of the attribute is. And you'll see that they've got encoded fields inside them. Each of them has got at least 3 fields, and sometimes there's a 4th one necessary. So if you take a look at the addition of an attribute on the first paragraph, the fields are the change transaction identifier, which we saw in the addition and deletion of elements. The second field is what type of, what has happened to the attribute, whether it's been inserted, removed, or modified. And the third field is the attribute name. Now, sometimes we need to have a 4th field, which is the old value of the attribute, but we'll get to that on the third example. So you can see on the first paragraph, it's important to note that everywhere where there is a paragraph change, the current attribute value is stored on the element itself. So the first paragraph has style equals my new paragraph style as an attribute. There's the attribute encoding of the change to show how that has been added with the change transaction insert, but the actual value is stored on the element itself. So if you ignored the change tracking information, you would have the current form of the paragraph. Then if you want to remove an attribute, again, the latest version of the attribute is there. That's nothing. And the attribute change shows us that we removed the status attribute. And there we have the fourth field, its value when it was removed, which in this case is draft. Then the final example is an attribute change. You can see that the second field is modify. So it's the attribute that was changed as a subject attribute. Its latest value is stored on the element, subject equals meteorology. And its old value is stored within the encoded attribute change. So that's the final field of that attribute change, which is weather. Again, you don't want to be adding and deleting elements to show textual content changes within a paragraph, for example. So similar to attribute changes, we've got the fine granularity constructs for showing textual change as well. So here we see the content of the paragraph changing from the weather in Prague is snowy to the weather in Prague is cold. We need to keep flipping that around these last couple of days. It was snowing yesterday, but it isn't today, and who knows what will happen tomorrow. So we don't need any modification. We just need addition and deletion of text. You'll see the word snowy is wrapped again in this removed content, which is the standard element to wrap any deletions in. And then the inserted text, so that it remains in its current context, isn't wrapped, but is marked with a start marker and an end marker. That's the inserted text start and the inserted text end. They're linked together with an ID and an ID reference, so that when that document keeps having more and more changes made to it, if they get separated, they are linked together by the ID. So as I say, they may in the future be in completely different paragraphs depending on what has happened during the editing of this document. But when they're created, they're always siblings of each other and have only text nodes in between them. So that gives us level 1. So element addition and deletion, attribute addition, deletion, modification, and text addition and deletion. For many formats of XML, that might be enough. You might think, well, what else is there we need to do? And that can be generally useful, and that's why we've kind of called it level 1. This is usable. But there are extra things that we can do. We do have a demo which I'll hopefully show at the end, as long as you don't crash it right now, and where we can see that these level 1 constructs can be created. I'll hopefully show you that if we've got some time. So it is possible to use level 1 to describe more complicated changes. So let's say, for example, we have a paragraph with a word in it which we want to make bold. In many languages, grammars, that would be wrapping that word in a span with some kind of style. So here is an example of that, using the level 1 constructs. So we remove the word snowy, and then we insert a span with a style of bold with the word snowy inside it. So all we wanted to do was make our word snowy bold, and that's how we can represent it. The problem being that the user will probably say what the title of the slide is. That's not what I did, because what they'll be showing is a deletion of the word snowy and then an addition of the word snowy in bold. All they want to see is that they've made it bold, for however that's displayed. So we have this extra construct for defining hierarchy change that doesn't change the underlying content of this structure. The solution for this, and this is exactly the same example, is to use a new insertion type attribute, which I hope you can see there. It's insert around content. So this tells us that the span that we've added to make the word snowy bold hasn't included the word snowy in its addition, but has simply been wrapped around. Another common thing we might want to do is to merge two elements together. That has been given its own construct in level 2 as well. And here is an example. So we have a paragraph followed by an unordered list followed by another paragraph. I hope you can see the highlighting. As follows down to should be is highlighted. It doesn't come across brilliantly on that screen. But if you imagine that the user has highlighted that with their mouse and they're about to press the delete key, you'll see that the final paragraph would read, today's weather forecast for Prague is good and the humidity will be 75%. There are three parts to this deletion, and I want you to remember them so that the XML on the next slide is not too confusing. There's the first part, which is the trailing end of the first paragraph, as follows. Then we have the list itself in between the two paragraphs, and then we have the initial part of the final paragraph, which is the kind of leading part of the final paragraph. And here's how we would represent that in XML. We have the delta merge element, which is a removal, and so it uses a removal change ID ref. And you'll see that that represents the whole of those three parts of the deletion that I told you about. If we remove the delta merge element from that context, we get the final paragraph. Weather forecast for Prague is good, and the humidity will be 75%. But then that merge then has the three parts of the deletion. The leading partial content element contains the text that was in the first part of the merge. The intermediate content contains a complete subtree, well-formed subtree of any elements that were in between the two elements that were selected as the start and the end of the merge. And then the trailing partial content contains the content that was at the beginning of the final paragraph. It contains slightly more. I don't know if you notice, it's slightly different from the leading partial content in that it has an element inside it. That enables you to have the final part of the merge as a different element name from the start. So let's say, for example, that had been a heading 1. So we selected from a paragraph across the list into a heading 1. That's still doable. We'll end up with a paragraph, but this, in the trailing partial content, will store the fact that a heading 1 was the original element in the end of that merge. So that gives us level 2. I've shown you element addition around existing content with the span. I haven't shown you element deletion leaving the content in place, but if we've got time, we may look at an example of that later. I've shown you an example of a merge, and then the other construct that we have is a split, which, for example, you put your caret inside a paragraph and you press enter and you get a split. This gives finer granularity of change than the level 1 did. It enables us to do some more powerful things that are more akin to what you see in an editor, rather than just adding and deleting or modifying. There's that concept of selecting huge chunks and deleting or rearranging paragraphs. So to summarize where we've gone already, we've got a generic representation that I hope you could see will work for any type of XML, any type of grammar. And if we have a processing instruction representation, then requires no change to grammars at all to support it. Level 1, the simple change types give you that basic change tracking capability. And then we've added extra constructs on top if you need them for your particular format, which gives you that finer granularity. Includes the constructs for merging and splitting and other common editing operations. We have completed the implementation of that. It has been tested in that we've managed to generate it. We've also managed to write XSLT scripts to roll back changes or to extract any given version from a document with this change tracking in. What we do need to do is more work on how you define conflicting change sets. So, for example, if you have a whole stack of change sets defined for your document, it may be that if you reject one partway down the stack, that has an implication as to whether you can accept or reject other changes. The way that is defined needs to be thought about and included. And we haven't. There are alternative representations, such as the processing instructions or kind of options to how you display different types of changes that still need more work. But as Mohammed and Robin have already said, please join the community group and give your input. So we have this level 1 demo, which, if we've got time, I will show you now. OK, so this is where you would go to if you go to the URL I showed. It's just a redirect. Here we have 2 documents, and then track changes are shown on the bottom. I'd like to point out, though, that this is not an editor. tracking edits. It's using a comparison, DeltaXML core comparison engine under the hood. And so every edit I make is going to be presented as a single change transaction. So the first thing I need to do, so that I don't embarrass myself, is to remove the "Hi Dad, if you're watching" paragraph. We'll have a text change here. The weather in Prague is snowy. And we'll add a new paragraph. Whoops. I know I am. So I hope you can see the paragraph I removed has been wrapped in one of these remove content elements. We have the example that I gave for the text change, where we've got to remove content with the deletion of the word cold and insertion of the word snowy. And then we've got a new paragraph, which has the insert with content attribute on it. Have a play with that. As I say, it only does level 1, just because of the way that the change tracking is generated is not tracking the changes that you make in the editor. It's comparing two documents. And so the level 2 constructs, it's not possible to determine those. It's going to go all the way through that again. That's me done. Any questions?
So, few minutes for questions. Yes, George.
It's an interesting work, and probably if W3C, this working group under W3C Community Working Group will reach a conclusion, we will be happy to implement this in Oxygen. What I didn't see in your examples, however, is tracking, keeping also different author information, because there's an entire level that adds complexity on top of track changes if you keep also different authors. And then when you record changes as you edit, what happens when you change inside the change, because someone can go and change in the middle of an insertion of another author and so on. So these changes, when you add also this dimension of different authors and allow another author to change in the middle of another author's change, things get more complicated.
Yeah, I mean, perhaps I wasn't clear on when I talked about change transactions. If you see here, we've got this extra element that's been added. So the two examples have got the same root element, but we've wrapped that just for the sake of this example and inserted this track changes element, which lists the change transactions. There's all the information there that you need. That you can put metadata in there, so the author, the date, whatever you'd like, so that each change refers to that change transaction. So each change has got an author associated with it. And we have tested, I didn't include examples of nested changes. So if you've got an addition of a paragraph and another author then makes some deletions to that paragraph, that all works. Those examples are a bit too complicated to fit on one slide.
Yes, but from our experience, the behavior can be different if it's the same author that adds additional changes, or if it's a different one. Because if it's the same author, you just extend maybe an insertion, right? If it's a different, you need to split that. So as I said, it's another dimension if you take also authors into account, and it's also a temporal change of the, of this information. Yeah.
I mean, whether you extend a change if it's the same author or whether you create a new one is almost an implementation detail, I think. I don't know if you agree with that, Robin.
Yes. I think, yeah, to some extent, George, I think I'd reply, well, that's your problem. I think within the editor, certainly you have the facility for treating those things differently. And as you say, users would expect them to be treated differently. But the representation is there to support whichever way you wish to represent that.
1 minute for 2 questions, probably Jonathan.
Okay, I was missing some of the assumptions, the scenario that you're working on. It looks like you're assuming that out-of-line diff markup isn't important. It looks like you're doing something that's essentially a diff, but you're also treating it as though you sort of know what the intent was of the changes. You're saying that they inserted something into one of the paragraphs, when really you only know that 2 of these paragraphs differ. So I need the big picture behind this.
Yeah, this example perhaps maybe this is a comparison, this particular example, but that's just to show how we would generate. I mean, our background is in XML comparison, so that's what we've used to generate these changes. There's no assumption that you have compared to generate the change tracking. It can be real-time change tracking in an editor. And so if you've got that information, the way that you encode the change is always going to be different.
So if I think of this as real-time change tracking in an editor, that's the main line scenario that you're thinking of?
It's a way of showing change tracking information, however you've derived that, whether that be by comparing 2 documents or by being an editor and knowing what the author is doing.
Doesn't the model wind up being a little bit different if you know? I mean, there's a big difference between knowing that somebody changed this paragraph and knowing that there was a paragraph here and now there's a different paragraph there, and you don't know anything about the relationship between those 2.
It can lead to different results, yes. But the representation all it's representing is change.
Implementation defined.
Just to add something to that, I mean, in terms of the big picture behind this, the principle is that there is a timeline of changes that's going on. How you get to those changes, whether it was actually tracking the changes or doing a comparison, is another issue. And certainly you're absolutely right that when you do a comparison, you can't work out what somebody has actually done. And therefore, the real-time change tracking within an editor will always give you a slightly different result from comparison. That's absolutely correct. The change tracking representation would allow you to do either of those scenarios.
Okay. Uche.
So, in some of the applications of diffs and comparisons, etc., things do tend to be bundled with the authoring, I know, like MS Word. But in many that we're familiar with, like revision control of code, it's managed out of band. So I'm curious about the fact that it seems like a fundamental assumption here is that the revision information will be in band, and whether you're thinking of a version of it that could be processed out of band, because I could tell you in a lot of applications that I've dealt with, I wouldn't want it in band like that.
Absolutely. I hope you can join the group and help us to develop that as well.
Well volunteered.
Yeah. You're absolutely right. There are, I think, applications where having this stuff external would be great. And I would love to be able to convert, as the vision is to be able to convert from markup to processing instructions completely losslessly. It would be lovely to be able to convert from an internal representation to an external representation completely seamlessly as well, so that you can take the appropriate representation. I mean, that's the great thing about XML. You can change the representation to be appropriate for what processing you're doing. So, yes, absolutely.
Michael?
Have you looked at all at moving or reordering of content as a primitive?
Yes, but I didn't get onto that.
Yes, that is there, the concept of a move, which essentially is an add and delete that is linked together. And also considered with that is the situation where you move a paragraph that's actually been modified, then what happens to that? And we've considered those sorts of scenarios as well. So, yes.
So you can continue this discussion on the community group. So I would be very happy that you join every people that ask this question. So thank you again for this presentation.